So we have a function transforms a group of numbers in group A into new numbers in group B. We represent this verbally, we represent it numerically. An example of this would be, let's say we have x and the function f of x. Let's say we're testing these 3 points. The language says 2 is added to the number. So -1 plus 2 is +1. 0 plus 2, 1 plus 2. This is a numerical representation of the function as a table of values. We can also do this graphically. Let us sketch an x and y axis. And let's pretend to add some numbers in here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Okay, based on the numbers we just got on the numerical table of values, -1, 1 is here. 0, 2 is here. 1 and 3 is here. Here's my graphical representation of the function that I'm talking about. We can also if I'm going too fast, just shout. Algebraically. We can represent a function algebraically. This means writing a mathematical equation to represent what we're talking about. The function takes x and adds 2 to any number. We're okay with this? Beautiful. Let's flip the page. Okay, when we are talking about relationships between the numbers, you can either have a relationship which is anything on a graph. We call it a relation. Anything on a graph is a relation. However, not all relations are functions. Functions have to pass these 3 tests. Number 1, pass the vertical line test. And from now on, VLT, I'm not writing that out again. The squeegee works too. We want distinct or unique y values. Distinct y values for each x. And when we write the equation, no y's in the equation. Okay, I'm going to demonstrate what that means. Anybody remember what the equation of a circle is? What is it? X squared plus y squared equals r squared, where r is a radius and it is not a variable. Yes? This is a relation. However, it is not a function. To make it into a function, I would need to solve for y, because here y is part of the equation. So I move the x over to the other side and take a square root. Now I have r squared minus x squared, all square rooted. This is now a function. Because the y is not part of the equation. Does that make sense? Okay. Okay, The machine is what we call f, the function. We put in x values, or we call this the domain. The possible x values that we can put inside of the machine, and the machine spits out y values, which we call the, come on, that was supposed to be a chorus. The range, thank you. Okay, so f of x is the machine that does it all, y is the end result, and x is the input. However, there are going to be times, many times, where we have an intermediate machine. We have a composition of functions where this is g of x, and this is f of x, and we have a bit of a chain reaction. We put in x values in the domain of g, and g spits out g of x values, which is the range of g. But g then puts it into f of x. So f of x, the domain of f of x, is the range of g of x, because it's a chain reaction. G of x goes into f of x then spits out a y, and this is the range of f of x. So we can have a chain reaction, a function inside a function. We call the input independent, and we call the output dependent. So far, so good? Mm-hmm. All right. Okay, we do this arrow diagrams. We're not going to do this much, so I'm actually going to skip this part. I don't want to go over it. But I am going to talk about writing domain and range in different ways. So domain is allowable values of x, and range is allowable values of y. So I'm just going to put y in brackets and x in brackets here. Different ways that we can represent x and y values. Okay, we can say x epsilon double line r. What does that mean? Element of r, or x can be anything. It can be any real number. If I have a restriction, I can say x cannot equal 0, for example. This is an example of a restriction. I can say x has to be between -5 and, oopsie, +5. Notice my arrows and the line under my arrows. What's the difference between this arrow and this arrow?
Wait, no, it can't equal -5 and it can equal negative.
Okay, so -5 is included. +5 is excluded. Okay. So under the range section, I'm going to show you another way we can write this, but with the same restrictions that you see here. We can say y can be all real numbers. That's fine. We can say y. I'm going to show you how to write this in a different way. I'm going to say y can go from infinity to 0 and from 0 to infinity. Sorry, this one should have been negative infinity. Means it can go on and on and on forever. When we use round brackets, this means cannot touch or cannot be included. Square brackets means you can include it. So we call this interval notation. This means the same as this, cannot be 0. goes off to infinity, comes to 0, but doesn't touch it. Goes off to infinity in the positive direction, but doesn't touch the 0 because I have round brackets around the 0, cannot touch it. So here, x can be between positive and negative 5. I include the 5 though. So I could write it this way. The domain includes negative 5, but excludes positive 5. That would be another way I could write this. We're going to use all these different ways to express our domain and range. So round brackets cannot touch, square brackets can touch the domain and range. How much do I want to do more? Okay, I'm going to stop here for a second. Stop recording.